Okay, we have three expressions: y equals 3x plus 2, y equals x squared minus 4, y squared plus 25 equals x squared. For each of these expressions, we want to replace x by negative x, then we want to replace y by negative y, then we want to replace x by negative x and y by negative y. Well, that's easily done. Y equals 3x plus 2, we replace x by negative x, we get y equals 3 times negative x plus 2, which gives us y equals negative 3x plus 2. And I put an x next to this, that's actually kind of a cross-out sign, to indicate that this is not the same as this. This would depict a line with slope negative 3, this a line with slope positive 3. They both have the same y-intercept, but they would have completely different slopes, so they're not the same. Okay, if we replace y by negative y, then we get negative y equals 3x plus 2. We get y equals negative 3x minus 2. That is, got a cross-out sign on it too. It isn't the same. And what we're trying to do is determine whether what we get is the same as what we started with. This has opposite slope, and it has a different y-intercept. Clearly not the same graph. Okay, now replace y by negative y, x by negative y here, negative x here, and we simplify. Now, when we simplify, we get negative y equals negative 3x plus 2. And I said we're getting somewhat hopeful here this is going to work, because when we multiply by negative 1 to solve for y, we get y equals 3x, which so far matches. But then we're going to have to take the negative of the 2, so that doesn't work either. So this is different than this because it has a different y-intercept. Same slope, different y-intercept. You'd have parallel lines here, but they wouldn't be the same. Okay, now, next expression is y equals x squared minus 4. We replace x by negative x, we get y equals quantity negative x squared minus 4. Squaring negative x, we get x squared. That's the same as the original equation, so that one matches. Okay, replace y by negative y. Okay, well, replace y by negative y, we get negative y equals x squared minus 4, so that y is negative x squared plus 4. Clearly different. Among other things, the y-intercept of this would be 4, whereas the y-intercept of this is negative 4. The negative x squared and the x squared would also cause one to open upward, another to open downward, but we haven't gotten to that point yet. I didn't do this one where we replaced both, and you might want to do that. Turns out you're going to get the same result you did when we just replaced the y by negative y. So you're going to get the same result we got here. So check yourself on that if you like. Okay, now we got y squared plus 25 equals x squared. Replacing x by negative x, we get negative quantity x squared on the right-hand side. Left-hand side is unaffected. But squaring negative x, we get x squared. So this is the same as this. Now, just as I did here and didn't mention it, I put a red circle around it and a check mark. And put the check mark here. And I've got a red circle around this and a check mark, indicating that this matches this, indicating that this matches this. Now, I didn't do the replacement of y by negative y, but I did do the replacement of both x and y by negative x and negative y. Replace both x and y by their negatives. And clearly what we get, y squared is going to become negative y quantity squared. X squared will become negative x quantity squared. But then negative quantity y squared is just y squared. Negative quantity x squared is just x squared. And that gets us back to our original equation, so we get to circle this one also. Now these graphs don't represent the graphs of these functions, but this represents what happens when replacing x doesn't change the graph. You have symmetry with respect to the x-axis. So, if we replace x by negative x, and get the same equation, we have symmetry with respect to the x-axis. And that looks like this. What you have below is a reflection of what you have above. Now I'm going to write a couple of comments on these two pictures and make a couple statements there. Okay, I need to quickly make a correction. You get this symmetry when you replace y by negative y. And that gives you symmetry with respect to the x-axis. Okay? In this case, but if you replace x by negative x and get the same thing, that means you have the same y values for x and negative x, and that's going to give you symmetry with respect to the y-axis. So if we replace x by negative x, it gives us this, symmetry with respect to the y-axis. If replacing x by negative x gets the same equation, gives you the same equation, then you have symmetry with respect to the x-axis. You have the x-axis here. What's on this side and what's on this side are mirror images. Okay. Now, if you replace x by negative x, that's a bad looking x there, let me fix it. Okay, again, if you replace x by negative x and y by negative y and get the same equation, that implies that you have symmetry with respect to the origin. Now, that would mean that you got part of a graph up here, you'll have the part of a graph down here. And the relationship between these parts is that this point would reflect through the origin to give you this point. This point here would reflect through the origin to give you this point down here. Now, it's not perfectly drawn, but you should get the idea. Every point up here reflects by a line through the origin to a point at an equal distance on the other side to a corresponding point down here. Then that will be the case. That's what symmetry with respect to the origin means. And the test is you do these two replacements, both of these replacements.